Hello and welcome to the next episode video of Beginning GameMaker. And today we'll be building a complete game and basing it on all of the things you've learned so far, or we've covered so far, and we'll be introducing a few more things. The game's going to be incredibly simple. We've called it MineKeeper, and I'm just going to give you a demo of it right now. So the idea is you have to lay 100 mines without exploding 100 mines. So you lay a mine by pressing the enter key. In fact, that's all you do. It's a very simple ball sprite. It lays it randomly on the screen. As you can see, I haven't collided yet, and there's a collision just there. So you have to get to 100. Score's going up, and if you hit one, both explode and you get -2. So you either win when you get to 100 or you lose when you get to 0. I'll keep on going until I either win or lose, and we'll speed it up in the edit. There we go, I won. Okay, let's crack on with the coding of the game. In the next part, we'll create a new game and we'll come back once we've added all the assets. So, as you can see, we have saved a game called MineKeeper into our Documents GameMaker folder. And we've created some assets, so let's go through these. So we've got 3 sprites. The first one is the mine, which is just a basic ball. The second one is the background, which is the size of the room, 1280 by 720, with middle center as the origin. And the third one is an explosion with 7 frames going at 12 frames per second, so it looks a bit like this. The size is 64 by 64 and it's on a transparent background. Now we have also created 2 rooms, one called room win, one called room lose, or rm_lose, rm_win. There's nothing in those rooms, we just created them. We've also created 3 objects, the wall, explosion and game. We've associated the ball sprite to the ball and the explosion sprite to the explosion object. And object game has no sprite. That object should be persistent across all the rooms, and so we will make sure it's added. Yep, it's already added. Just drag it in to add it and make sure it's persistent here. So there's only one instance of it used across every room. The one thing we need to do before we finish this part is set the background in the room. So if you click on background layer, not instances layer, and set the sprite to SPR_BG, and that's the end of this part. In the next part we'll be coding the MineKeeper mines so we can lay them on the screen. So in order to get a truly random spread of mines when we lay them, we need to actually initialize the randomizing system in GameMaker by calling a function called randomize. So we're going to do this when the room is started. So open your room up, and in the creation code for the room, just type randomize. If you start typing random, you'll see the function come up with the IntelliSense in the editor. Select the function, see functions are in orange, randomize, and I'm going to put a semicolon onto that at the end. You don't have to, but I tend to do that just to mark the end of the line. Now, I would advise you to put a comment as well, because you might forget what this is all about when you come back. Make the random numbers truly random. You can't really make anything truly random in a computer program, but it's effectively truly random. What it means is if I didn't have this, then every time you played this game, it would come up with exactly the same random numbers every time, which would be totally ridiculous. So I don't know why anyone would want that. I think they should do this automatically for you, but you have to do it. Anyway, the next bit is we need some variables. So in our game object game, we're going to create some variables in the create event. So create yourself a create event. And in the create event, let's just put create the variables that we need. Exclamation mark. So we're going to need a variable for the score. We're going to call that SC, because if you call it score, it kind of clashes with the inbuilt score variable. See, when I type score, it says built-in variable score. We're not going to use that. We're going to use our own. Better to use your own because you have more control over it. And we're going to set its initial value to 0. And I'm going to add a comment for all of these in a minute. We're then going to have a variable called number of explosions left, as in how many explosions to go before we get to 0. We have to keep a count of that, otherwise we're never going to know where we are in the game. So we call that num xpl left, and we start off with 100 explosions that we're giving ourselves, and once we get down to 0, that means we lost. Now, they're global variables. We're going to create some property variables for the timer. We're actually going to put a timer in here. It doesn't really have a lot of impact on the game. It's more, I guess, just because we want to, or just because we can. We could use this timer for something later in the game. So we're going to put it in anyway. And this is our own coded timer. So it's not essential for the game. You don't really need it, but we're going to do it. So I'm going to comment all of these. Notice I put all my comments on the right here in a column so they can be read easily. Okay. So score, number of explosions left, time elapsed in seconds, time elapsed in minutes, and finally number of frames elapsed. And obviously that's going to be 0 to 59 before we get to the first one again, because we're going at 60 frames per second. Okay, so that's all our variables. Now we want to create an action event. And what I mean by that is when the user actually does something. So in this case, when the user presses the enter key, presses it, not holds it down, we are going to create the mine. So let's add a key press event or enter. And comment, add a mine when key is, well, enter key is pressed once. So we want to create a random coordinate. So we're going to use one of the random functions in GameMaker and put that coordinate that it creates in a variable called xx. And the reason why we're calling it xx is because we are wanting a coordinate, an xy coordinate, but we can't put xy because, again, x and y are built-in variables in GameMaker. You see, if I type x, it's green. That's a built-in variable. So we're going to use xx and call the function. If you just type irandom, you'll get both functions come up. But we're going to use the function iRandomRange because we want a value between 32 and 1000, because that will keep our mines on the screen, because the mines have a default center, the sprites have a default origin of middle center. Okay, and var yy equals pretty much the same, except we have a height of 720, so we're gonna have 688, 64 to 688. So we're going to end up, when this code runs, when we hit the enter key, it's going to run this line of code and this line of code, and xx is going to have a value between 32 and 1248 inclusive, and yy is going to have value between 32 and 688. And then we're going to dynamically create an instance of the object ball, and we're going to put it on the screen at xxyy. And how are we going to do it? I'm glad you asked. Like this, with a function called instance create. So we're creating an instance layer, because we're creating an instance on the instances layer, not the background layer, the instances layer. Remember, when you drag an object into the screen, it's on the instances layer. So we have to create an object dynamically on that layer, and we have to give it a coordinate, which we've already worked out. Will come in as xxyy. Then we give it the layer. Remember, if you look down here, you can see exactly what you need to supply to the function. We need to supply the layer ID, which is or layer ID or name, and that is instances, and we do that inside quotes, so it is a string. And finally the object, which is obj ball, and that's an object type which GameMaker knows about and handily gives you a whole list of all the objects, which is why we prefix all our objects with obj underscore. Okay, so they'll all come up in the list when you want them. Let's say, what if you were building in like a massive game and you had hundreds of objects? If you named them all differently, then how are you going to see a list of them? If you name them all obj underscore, you'll see a list of hundreds of objects, all the objects you've got, and they'll be in alphabetical order. Right, so obj game. And we should actually be able to run the game now and lay mines, so let's try it. And it's not working. Do you know why? That wasn't deliberate, by the way. It's a thing I always forget to do. And I always say that I always forget to do it. It's quite weird, really. And what it is, no, it's not that. I thought it was because I'd forgotten to drag the object into the room, but of course you don't need to. So what is it then? Well, let's go through the code. So when we load, we load the room up. We know the room is the initial room because it's got the little house there. So we know when the room loads up, it's going to call randomize. And we know object game is created, so it creates all these variables. And we also know when we hit enter, we create an instance of the ball. I put object game. I don't want object game, I want object ball to be created. Okay, let's run it again. Okay, so if I hit enter now, there we go. Hit enter again, and again, and again, and again, and again, and again, and again. There you go. Ball's being deposited in the room when I hit enter. Because when I hit enter, every time I hit enter, these 3 lines of code are run. We get a new random coordinate and we create an instance of object ball on the instances layer at the coordinate xxyy. And there you go. So in the next part, we're going to make the mines draggable, which gives you a little option. If you're playing this against someone else, you can be strategic and move your mines to whichever place you think is going to help you win the game. Hi, so in this part we're going to make the mines draggable. Now to do this we employ a little technique that involves a Boolean variable. If you remember, a Boolean variable can have one of 2 values. It can either be true or it can be false, and certainly with games and usually any kind of system, it comes in very, very handy to use Boolean variables because sometimes something can only be true or false. So for instance, we are going to create a variable called drag, and it is going to be either true or false. When we press the left mouse button when we're playing the game, drag is going to be true, and when we release the mouse button, drag will be false. And in our code we will drag, or we will move the balls, the mines, when our mouse left button is pressed over the mine. Okay, so if that sounds hard, it isn't. Let's show you how to do that now. So we first need to create event in our object ball and just create that variable drag equals true. And maybe I'll put a comment as well. Or actually drag, do we want drag it? No, drag equals false because we won't be dragging to start off with. And I'll put a comment, say tells us whether we can drag the mine or not. Now we need a left mouse down and left mouse up events, which is actually, what are they? Mouse left down and mouse left released. So in left down we're going to set drag to true, and in left released we'll set drag to false, and that's the manipulation of drag. Now we need to actually move the mines around based on whether drag is true or false. So we want a step event, so because we're going to have to check every single frame whether the mouse button is down or not. So let's create a step event and say check if we can drag this mine. So every mine is going to have this code. When we create a mine, each mine is going to have its own bit of code that it runs. So we're going to say if drag equals true, using an if conditional statement, do you know that? And remember, comparisons are double equals, not single equals. If I said drag equals true like this, I'd be setting the variable drag to true. I don't want to set the variable drag to true. I want to compare and say, is the variable drag equal to true? Are the contents of the drag variable true? If I reached into my storage bucket called drag and pulled out the value and read it, would it say true? So if drag equals true, and then remember you always have to have braces after that, because if it is true, then you'll run the code inside of the braces, and all we're going to do is set the X of the sprite, which is middle center, to the mouse X, so the cursor, and do the same for Y, which basically means for the duration that drag equals true, we will actually follow the mouse with the mine. Okay. So let's run it and test it. Right, so we're going to move these ones apart. There we go, so we can actually move. When my left button is pressed over here, drag is now true. So it's going to set the XY coordinate of that ball to be mouse XY every single frame. So if I move the mouse, obviously it's going to set it, I move the mouse super fast, you know, 60 frames a second, I have to move it extremely fast. I'm probably not that fast. So there you go. In the next part, we'll be looking at creating the score and drawing text to the screen. Next, we're going to update the score and make sure it displays on the screen. Now that's pretty easy, although you do have to remember or know how to draw text to the screen. So in our main room, we want to create a draw event. So let's do that. Let's close this one. And actually we want to create a draw event in our game object. That's where we'll draw to the rooms itself. So let's add a draw. And let's put a comment in, draw text to any room. So I'm going to set up a constant or a variable, a local variable first. It's going to be called C, and I'm going to call it, I'm going to give it a value of the constant C yellow, because we're going to draw it in yellow and I don't want to have to write C underscore yellow loads of times. I'd rather write C And then we're going to say if we are in room 1. Now we use the built-in room variable. That's really the only built-in variable we're using, because that's actually pretty useful to know which room you're in. So if room equals, as in double equals, room 1, then I'm going to use the function draw text color, and just use the arguments and parameters at the bottom to help you know what to put in here. So we want the XY coordinate of where we want to draw this text. So we want to put it at the top of the screen in the middle. So roughly in the middle would be the room width divided by 2 minus something. So room width, fortunately, is a built-in variable, so we can use that. So that will actually be, we know, 1280. We're just going to divide it by 2, which kind of gives us the halfway point. But because score and the actual score is going to be a certain length, we actually want half of that length again off of where we're drawing this. So let's just put minus 40 for now. And then we want the Y coordinate, which is simple, 20, which is 20 pixels from the top of the screen. And then we want what we're actually writing. So we're going to write the word score and add to that the string, and the score is what? Global SC. We know that, that's our score. And the next thing is the color. You have to give 4 times, which is why I didn't want to type C yellow. And the alpha transparency, which is going to be 1. Usually going to be 1, that. And that should be it. Now, let's run the game to check. Yep, and then we have scores 0. Now, in object game key press, we want to add some more code. Now, we want to increase the score when the key is pressed. So how do we do that? We add 1 to what? Yes, global.sc. So we could do this several ways. We could do this global.sc equals global.sc plus 1. It's adding 1 every time we press enter. We could say global.sc plus equals 1, which is exactly the same thing. Or we could say global.sc plus plus, which is what I'm going to do, which does exactly the same thing. And then we want to check if the score is greater than or equal to 100. If it is, we've won. And therefore we want to transition from room 1 to room win. So we have to have an if statement that says if, and this happens, this is checked every time you hit the enter key. But if global SC is greater than equal to 100, then room goto. That room goto is the function we use to transition to another room, and we just use the room name, room win, and that's it. So let's run the game. And we should see the score increasing as we lay the mines. And there it is, that's working. In fact, it will keep increasing as we overlap. As you can see over here, we've overlapped mines. We haven't exploded, obviously. And keep adding score. So in the next part, we will do things like destroy the mines, have the explosion in, reduce the score when we explode the mines, so make it more a little bit of a challenge. The next part of the game is probably the trickiest because we have to handle a collision between two instances of a mine or object ball. For that we have to understand that each ball on the screen is a different instance and has a different ID, which enables us to determine which object is which and enables us to write the code, as you'll see in a bit, because the issue we would have is that if we put a collision event in object ball, when a ball collides with another ball, there will be two collision events that will fire off, not one. And we really want just one collision event. So in order to sort of work our way around that, we will use the fact that each ball in the collision has a different ID. Now that might not make a lot of sense right now, but hopefully it will when we add the code. So let's add a collision event for the ball. So in object ball, collision objects, and choose ball again. And let's just say handle collision between mines. Now there's quite a few things to do here when they collide, and we'll go through them bit by bit. The first thing is we want to play a sound when the mines collide, but we only want to play that once, not twice. So the way we're going to get around this firing off twice is we're going to put an if statement. We're going to put self ID is less than other ID. So self is the object that initiated the collision, and other is the other object involved in the collision. Normally it would be like, say, a player colliding with a bullet, and self would refer to the player and other would refer to the bullet, or something like that. But in this case, self is referring to the mine that is placed, and other is referring to the mine that it hit. So they each will have different IDs. So we can say if the self ID is less than the other ID, then we will run this code, and this will only run once, because when the other collision event tries to run, this will not be true. Self ID will be greater than the other ID, because the other object is now the self object, and the self object is now the other object, because it's looking at it from the perspective of the other ball. Okay, so hopefully that makes sense. So run this code if the ball ID is less than the other one. Okay, so we want to play a sound. For that we use the audio play sound, and we use the sound ID sound explosion, S&D explosion, which we have already created. Give it a priority of 1 and don't loop, so that's false. Now we want to create the explosion object, so we use instance create layer for that, which we talked about before. And we want to do it at the position of the ball, which is XY. That's self, the self ball on the instances layer. and the object is object explosion. Okay, so that's that. The next thing we want to do is we want to decrease the score by 2 because two mines are being blown up here, which we're gonna destroy them in a bit. So we'll say decrease score by 2. So we go global.sc minus equals 2, which means, as opposed to saying global sc minus 2. Okay, it's just a short form. And we want to decrease the number of explosions left by 1. So let's do that the same way. Now, when we get to 0, what if we hit 0? We need to check if we're at 0, because that's the lose condition. We're just going to check if it's less than or equal to 0. And if they are, then we go to the lose room, which is done by calling the room goto function and just specifying the room. So room lose, that. And then we want to destroy both objects. So we'll write this code outside of the if condition, and because this event will run for each ball when they collide, each ball will be self in its own event. So we just say instance destroyer, and this will destroy the self object. So it will destroy both of them. So now we should be able to run the game. However, it won't update the text in either the room win or lose, and also we forgot to write in the number of explosions left. So we're going to do that first, and then we'll run the game. So in object game, we want to add a draw event. Ah, no, we've already got it. We just want to add some code to it here. So we also want to add the explosions remaining here. So let's create a variable for it first, because this could get long and messy. Okay, so that's that. So exp remaining is our variable, and it should say explosions remaining :space 100 at the beginning, because global.num left is at 100 as a number, and we turn it to a string. So we put string plus string equals one bigger string, and that string goes into the exp remaining storage bucket variable. So that's the value inside there, and then we use that variable, the value inside it, to draw on screen. So you go draw text color, and we're going to use the yellow again. This time we're going to put it at 4020 just to make it simple. We use the value of exp remaining, and we use C is the color and alpha is 1, and that should, and whilst we're here we're going to do the room win and lose condition as well, because they're going to be very similar. I think we will set the alignment of the text to center, and then we will use the transformed draw text transformed color, so we can make it bigger. And we'll put it in the center, and the text will be U1 or U lost depending on which room we're in. We'll scale it up by 3 vertically and horizontally, and we'll use yellow, and we'll set it as alpha 1, which we always do. Now all we need to do now is copy that, paste it underneath, change room win to room lose, change U1 to U lost, and we've got code for the lose condition as well. So now we should be able to run it, but I think we will encounter one issue, which we'll find out in a second. We have some errors. Wrong number of arguments for draw text transformed color. Okay, so we have, let's follow this with the bottom of the screen, the bottom here, where we can see what we're supposed to be doing. So that's X, that's Y, that's the string, that's X scale, that's Y scale, angle, or angle 0. And that should be in the one below as well. Okay, let's run it now. I don't know if you're going to be able to hear these explosions. I'll tell you if I can. Yeah, I heard the explosion, but you can see the problem. The sprite stays on the screen forever. So we need to actually play the sprite once, then destroy it immediately, and for that we need a timer. So let's talk about timers. We need to go into the explosion object, and we need a timer, and we need to trigger the timer. So we're going to add the timer first. It doesn't matter which order you do this, but this is kind of more logical. Destroy the instance, and simple as this. Instance destroy, that'll destroy it. But the thing is, we want to destroy it after about half a second, I reckon. So we need to create a create event, and we need to call the timer, trigger the timer, let's say. And we do that by specifying the alarm, so it's alarm 0. So the alarms are in a list, and if you may remember, lists or arrays can be accessed via square brackets. So alarm is a list, and alarm 0 means the first alarm in the list. So to trigger that, we say equals a certain amount of time. We're going to say half, for half a second, times the room speed, which essentially means the number of frames you have it set to, or that it's able to do. So that if you did 1 times room speed, that'd be pretty much equal to a second. So half would be half a second. So after half a second, the alarm is going to trigger and going to destroy it. So the alarm's only triggered once. So let's see if that works. So as soon as it's created, we call the alarm. Half a second later, it calls it and it's destroyed. So let's see if that works. And if it does, we have completed the game. So we might as well see if we can win or lose and see what happens. Okay. There we go. Explosions, perfect. All right, let me carry on. See if I win or lose, and see if we get the text when the room transitions to the win room or the lose room. See, the ball's covering the score there, which is something which should be fixed. We're about to win. There we go, we won. Perfect. Now for this game, just to conclude, we would like you to try some extra little niceties on top. Like you can change, there's all kinds of things you can do. Well, you could change the mine sprite to a mine, or if you didn't want to, you could make the ball a random color. So every ball's a different color. You could add a sound for when the mine's placed. You could change the numbers, so you need maybe 50 to lose, it's 100 to win, or 200 to win. You could add a start room where you give the user instructions how to play the game. You could change the explosion sprite, change the explosion sound. There's so many things you can do. You could actually animate the sprites so they move and they explode into each other. If you actually manage to do some of these things, just leave us a comment and tell us what you did, how it worked out. But until then, next week we'll probably be getting back to our platform game and looking at gravity and jumping. So until then, stay safe. We'll see you again.